Ladies and gentlemen, today's lesson is on finding the volume of a cone. Quick reminder about what we've been working on. The other day we worked on how we could find the volume of a cylinder, but the formula looked different than what's on your new note sheet. The formula was just pi r squared h. The reason the volume formula for a cone is 1/3 pi r squared h, because when you have a cone with the same diameter circle, it takes 3 of these cones filled with water or any other substance to fill up the cylinder. And they also have to have the same height, as you can see. But it does take 3 of these to fill up the cylinder. So since we know that, we can actually keep our formula pi r squared h, but multiply by 1/3 in order to do our calculations and correctly get our volume for a cone. So remember, a cone has a circular base. The sides meet at a common vertex. The cone that we have been given in our first example, we're supposed to find the volume of it. So there is a couple things we just have to make sure we're clear about. The radius of the circle is down here. It is always the distance from the center of the circle out, so we need to make sure we use that for r. And then we have two other numbers in our picture. This is the actual height of the cone. They call this the slant height. Okay, it's because the side of the cone slants up to the vertex. You'll use slant height when you work on geometry in high school. For us, we use the regular old height, which is always perpendicular to the base where you will find your radius. Okay, so in this case, we are going to take 1/3 times pi times the radius of 12 that we just found. Make sure that you're squaring that radius, because in our formula the only thing squared is the radius, and then make sure you're multiplying by 5. One of the things we focus on at this level is sometimes finding the answer in terms of pi and sometimes finding the answer as a decimal. So we're going to practice both. Alright, what you're going to do first is you're going to go ahead and put in your 1/3. But we're not going to multiply by pi right away. We're just going to skip over the pi, and we're going to type in our 12 squared, and we're going to multiply by 5. So as you can see, we're entering all of our numerical values, and we get a nice answer of 240, but we will keep pi in our answer. This is when you are looking for your answer in terms of pi. We practiced a couple questions like that yesterday. But sometimes you want an answer that's approximated using the value of pi. So what we'll do now is we'll actually multiply by pi, and we'll go ahead and get this pretty crazy decimal answer, but we're going to write the whole thing down. The purpose of this is that sometimes we want to round our answer to a certain place value. I think in the practice sheets you're going to have to round to the nearest tenth. Possibly you'll have to round to the nearest hundredth, and every once in a while they'll ask you to round to the nearest whole number. So if we just practice rounding to the nearest tenth, this one's interesting because it does tell us we're going to round up. So that means we're going to actually bump the 9 up over here to become 754, and we do include the tenths place of 0.0. This problem does not have units, but if it did, we would have units cubed, because remember we're dealing with volume, and volume is 3-dimensional. Typically we have a length, width, and a height if we're talking about a prism. We have a cone, so we have a radius and a height instead. So for our second example, it says, hint, we have to find our radius before we can begin the work on this question. So in the picture what you've got is a height that is drawn perpendicular to the base. But this line segment here of 4 centimeters goes all the way through the circle. That's a diameter. So we need to find this dimension right here that goes halfway across. That is our radius. So half of this 4 centimeter segment is 2 centimeters. That's what we're going to utilize for our radius. So we have to plug in 1/3 times pi times our 2 squared times our height of 4. On the first line, remember, we are just going to plug in our numbers. So 1/3, skip over the pi, times 2 squared, times 4. All the numbers multiply to give me 5 and 1/3. I'm going to keep pi in my answer in case I want an answer in terms of pi. And if I don't, I will go ahead and continue multiplying that number that I just got times the value of pi. And again, now we're looking at a very large decimal with lots of digits that we'll jot down. And then again, if we're going to round, let's say we want to round to the nearest tenth again, we're going to look at this digit, but we bump it up again. So 16.8. This time we were given units, so we're going to say these are centimeters cubed, and that is our volume of 16.8 centimeters cubed. Now, the other note sheet that you're going to put in your notebook today talks about what would happen if we were to double the radius or double the height of a figure. So this problem says use the information from example 1. So I'm just going to sketch down what we had with example 1, at least the important pieces to it. And if you remember, example 1 had a radius of 12. This is telling us what would happen to the volume of our shape if we doubled our radius. So if our radius was originally 12 and we doubled it, that means we're using a radius of 24 right now. But it doesn't say to do anything to the height. So we're going to keep our height equal to 5 for this part of the example. And we're going to calculate our volume again, but using these dimensions. So 1/3 times our radius of 24 this time, times our height. And I almost forgot to square my radius, so be careful with that. We're putting in our 1/3. We're timesing by our now radius of 24 times 5, and we get 960 pi. So if I multiply by pi, I get 3015 and change. So approximately 3015.9. Obviously, it's a much, much bigger volume when we double the radius. And over here, what they want you to do is they want you to take that cone, and this time leave the radius the same as the original shape, but it says we want to double the height. So if our height used to be 5, they want us to use a height of 10. So let's see what happens when we double the height. This time we get 480 pi, which when multiplied out is 1507.9 and change. So 15.0 or 1508.0 if we're rounding to the nearest tenth. So as you can see, the thing that has the greater effect on volume is going to be your radius. Remember, the radius in the formula gets squared. So whatever that number happens to be, squaring it makes the volume much, much larger than just multiplying it by h, like in this example. So the greater effect on volume is doubling the radius. Now, the last problem that we're going to work on doesn't have a picture, so we could draw one if we wanted to. But it also gives us some information that's a little different. It tells us the volume of the cone is 405 pi inches cubed, and it tells us the diameter of the cube is cone is 18 inches. What we don't know is the height. So if we wanted to draw a picture, we could draw that. We know the diameter all the way through is 18 inches, and we know that we're looking for the height, but we happen to know the volume. So first, I'm going to have you write down the volume formula for a cone, and I'm going to have you plug in that 405 pi on this side, underneath the V, because normally when we work on these formulas, we plug our numbers right below what we have in the formula. Do we know our radius, and do we know our height? So let's see what we have. Our height is definitely missing. That's what they want us to find in the formula, so I'm going to keep my h up there. But I think we can work on finding our radius. If we know our diameter is 18, remember diameters go all the way through, that means your radius is 9. So I think we can do some cleanup with this equation. We're going to leave the 405 pi here for now, but on this side of the formula, I think we can do some work with the 1/3 times the 9 squared, and I think we can clean that up. So 1/3 times 9 squared is 27. That means I can replace the 1/3 and the 9 squared with this number, but I still have pi, and I still have my height that I want to find. So guys, think about this as being an equation that you want to solve. The first thing I think you'll notice is on both sides we have pi. Pi is attached to our variable by multiplying, So that means it's okay to go ahead and divide. The problem when you divide is you get rid of your pi's, but you still have this 27 here attached to your height. So that just means we get to divide one more time. And to finish up, 405 divided by 27 gave me a height of 15 units. So guys, if you have to solve for one of the missing variables, you can do so this way. Most of the time you're going to have questions that look like this, or like we'll talk tomorrow, we're going to put two of these shapes together and you'll be able to find the area of the entire figure. So now what you're going to do is you're going to tape your notes into your notebook. I believe we're up to page 91 and 92, and then you can start your classwork.